Okay. So can anyone confirm that my screen is visible and also my video is open and you can hear me as well? Hello, am I audible? Okay, thanks. Okay, me wait for a couple of minutes. I'll get started. Let me wait for a few more people to join. So I'll get started in a couple of minutes. Just waiting for a few more people to join in. Okay, so let me get started since five, six people have already joined. So hello everyone to this TA session on optimization methods for civil engineering NPTEL course. So I'll be one of the TAs of this course who will assist you to solve the assignments problem that will be posted every week. So before I proceed, just anyone confirm, I hope my screen is visible and my video is on and I am audible as well. So this session I'll be discussing about the week one problem. So the assignment has already been posted in your NPTEL page, course login page. You can see there. So the idea is to I'll be discussing similar problems so that that helps you to solve the assignment problems. So just to introduce myself, I'm Rita Brathanath. I'm a second year PhD student in the Department of Civil Engineering, Indian Institute of Science. So I'll be taking this TA session every Sunday from 3 p.m. to 4 p.m. And there will be another TA for this course, Antkrish, I think he's here as well. So he'll be taking another TA session from 4 p.m. to 5 p.m. So do attend both the sessions. That will help you pretty much in solving the assignments, and we'll try to like cover different topics in the weeks to come so that there is no overlap or something. So the idea of this TA session is that we'll be solving some problems that we have in our mind. That's pretty similar to the assignment problems. So probably I'll be solving some 3 to 4 problems in every session. And in between, if you have any doubts related to the problem that I'll be solving, you can just unmute and ask that doubt, and I'll try to clear that doubt there itself. And also, if you have any doubt related to the content of the week, that I hope that every one of you have gone through the lectures already, so you can ask that as well. So I'll be trying to wrap this up in 50 minutes, and the last 10 minutes I'll be probably asking you some whether you have doubts or not. And if you don't have any doubts, probably I'll just solve one more problem. So that's the idea of this sessions. So without further delay, I'll get started. And one more thing I wanted to mention is that maybe I won't be able to answer all the questions during these sessions. So what you can do is that you can post your questions in the discussion forum of this course, and I'll throughout the week, whenever I see them, I'll try to reply them and get your doubts clear. So let's get started. So the topics that I want to cover. So hope you are able to see my writing here. So the topics that I'll be covering in this class is that stationary points. Next is finding maximum and minimum of a single variable function. And the third one will be finding gradient in Hessian matrix of a multivariable function. So I'll try to cover this three topics, and I'll just give you some examples, and I'll be solving some problems related to this. So I hope that you have already gone through the lectures and already know this thing. So probably I won't be going into the concept directly, but yeah, whenever I solve the problem, if you have doubts, you can ask me. So let's get started with the first topic, which is on the stationary point. So let me give you one example. So this is example one. And whenever I write it down, it will be better that you also write it down with me so that you also solve this problem with me as well. So that will help you while you do your assignments. You'll be able to solve those problems pretty quickly. So let me give an example. Suppose I take a single variable function fx, which is say x to the power 4 minus 4x cube. Uh, so these people are joining in, so I'm adding them. So that's why I'm interrupting in between. So yeah, 4x square plus 4x square and minus 9. Suppose I have this function. So my question is find all the stationary points of fx. So before I proceed to solve, so I'll be trying to make this session more interactive. So I'll probably be asking you some questions in between. So, can anyone tell me what is the first step that one needs to do to find the stationary points? If anyone can unmute and yeah, Manohar, you can go ahead. Yeah, yes, yes. So that's exactly correct. So that's what I am going to do right now. So yeah, thanks, Manohar. So as Manohar mentioned that we need to find the first derivative. So what we have is the first order necessary condition, which I'll write it down. So this is also helpful while finding your maxima and minima. So that's why I'm writing down this condition. So that essentially tells you that f prime x, which is the first derivative of this function, has to vanish at that point. So suppose at x equals to a, it vanishes, then x becomes here, a becomes here stationary point. So now let me apply this to this function. So my f prime x is 4x cubed minus 12x squared plus 8x. So I need to equate it to 0. So while I solve, so this 4x will come out. So this is your x squared minus 3x plus 2 equals to 0. So that means your x times x minus 1 times x minus 2, that should be equals to 0. So now from this you can say that your x is 0 or 1 or 2. So these are your stationary points. So this is as simple as that. So that's how we can find your stationary points. It's just requires you to find out the first derivative of the function. And suppose, so this is my example one. Suppose I go one step further and give you another question. So find the maximum minimum of the function fx and where this maximum or minimum occurs. So now I have this function fx to the power 4 minus 4x cubed plus 4x square minus 9, and I know the stationary points are 0, 1 and 2. So now can anyone tell me how to find the maximum and minimum of this functions? Anyone can like unmute and tell me or raise your hand or tell me. Okay, Manohar already mentioned. So yeah, so I think anyone else can go ahead. I think anyone else? Yeah, yeah, you can go ahead, Diksha. Yes, yes. Yeah, that's exactly correct, and that's what I'm going to do. So let's proceed with that. So we need to get the second derivative of the function as Diksha mentioned. So now f prime x is, it was like 4x cubed minus 12x squared plus 8x. So if you try to find out the second derivative, so it will be 12x squared minus 24x plus 8. So this will be your second derivative. If you just Okay, just keep it this way, or you can just take 4 out of here. You can write it as, yeah, hope I have written it correctly. Yeah. So now you have already found your stationary point. So now the second order condition, so this says if x equals to a is stationary, yeah, so did anyone raise hand or something? Okay, if you have doubts, you can just directly unmute and ask me. Yeah, the stationary point, then if double prime a is greater than 0, then a is the minimum point. If double prime a is less than 0, then a is the maximum point. So now let's apply this to this function. So our stationary points are 0, 1, and 2. So let me put 0 here. So that will give me 4 multiplied by 2. It's 8. And this is greater than 0. Then next, if I put f double prime 1, that gives me 4 times. So this inside part is 3 plus 2, 5 minus 6. So that's negative. So this is negative. So this is again 4, this is 12 minus 12, that cancels out, and this is greater than 0. So from this, what we can tell is that this is a minimum point. This is another minimum point. This is a maximum point. So now, can anyone tell me about the concept, these two things? One is the local maxima or local minima. Another one is the global maxima or global minima. Yeah. Can anyone tell me what these two are? Anyone can unmute and or raise your hand and then can start speaking. Okay. Manohar has raised his hand. And anyone else wanna go because he has already spoken, or if not, then I'll ask him directly. Okay. So Manohar, you can go ahead and tell what these two things are. Yeah. Okay. Okay. Yeah, uh, that's true. Yeah, and what about the other thing? Yes, yes, that's correct. And similar things happen for the minima as well. So that's exactly what Manohar said. So now you know these points are actually your local minimum point or local maximum point. But you still this question asks you to find the maximum values. or minimum values. So now you can just plug these values back in. So now your fx was x to the power 4 minus 4x cubed plus 4x squared minus 9. And now if you put, so your f0 will be minus 9, your f1 will be minus 8, and your f2 so this will be 16 minus 32 plus this is again 16 minus 9. So in this particular example, it happens to be like both and 0 and 2 are giving you the same value of this function at both these points. So essentially both of them becomes your global minima in this case, and this is your maxima. So you had only one local maxima, so this is your global maxima as well. So this is the maximum value of the function, and this is your minimum value of the function. Yeah. So I think you will find similar problems like one function will be given, you have to find out the stationary points, then the maxima and minima, and that will be there in your assignment. So I think this will help you a lot. So I have discussed about this maxima and minima. So there is another concept. So let me go to the third example. So this is your point of inflection. So can anyone tell me what this point of inflection is? If you have studied it in the lecture, yeah, someone else probably this time can speak. You can unmute and tell me what it is. Or even the chat is fine. If you want to use the chat and answer it, that's also fine. Yeah, Manohar has again raised his hand, and anyone else? Like, if you, okay, probably if it's not convenient to answer in chat, I'll just ask some other type of questions which you can directly, like numerical type question, you can directly answer in chat. So, yeah, Manohar, you can speak. If you can go ahead and tell me what it is. Okay, okay. Mhm. Yes, yes. So that's exactly what Manohar said. So let us understand this more with an example. Suppose I give you a function fx, which is x to the power 4. Or, yeah, did anyone raise your hand? Okay, that's I think some earlier thing. Okay, so let us take this as x square. So now what you can do is that you can find out the first derivative. So this is your 2x, and if you set it to 0, uh, or I think I made a mistake, you should have, yeah, let's have x to the power 4 here. And your first derivative gives you 4x cubed, which is 0, and that if you solve, you will get x equals to 0. Now your second derivative, f double prime x, is 3x squared, and your f double prime 0 is 0. So now is x equals to 0 a point of inflection here? Yeah. So I want like most of you, if you can answer this question in the chat, yes or no, like answer. Mm, Okay, so I got one answer, no. What about others? Okay, okay. Yeah, I think, yeah, yeah. So I got like three no's. So I think, yeah, most of you have got it. So it's definitely not a point of inflection. So the answer is no, that's correct. So how can you tell for sure whether it is a point of inflection or not? So can anyone tell me how to proceed after this and finally conclude that it is not a point of inflection? Like mathematically, how can you conclude that? I'm not asking graphically or anything. So can anyone unmute and answer this? Yeah, yeah, both of you can speak. I think two people unmuted. Yeah, you can go ahead first, Manohar. Okay. Mm-hmm. Okay. Yeah, that's correct. Yeah. So Diksha, do you want to speak as well? Like, do you have? Yes, 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 exactly. So that's correct. Like both of you are correct. So the technique is that we have to go for higher order derivatives. So check for higher order derivatives. So now, if you take the third derivative of this function, that gives you 6x and it is 0 at x equals to 0. If you take the fourth derivative of the function, you get 6, which is greater than 0. So this is an odd ordered highest. So this is the highest derivative order, which is 0. And the immediate next one is greater than 0. So this pattern tells you this will be a minimum point. And this is again true. So if you probably draw the graph of this function, it will probably be something like it will this side it will increase and then something like this. So, so whatever happens, you either get positive values on either side of this zero, and at zero, this function takes a minimum value of zero. So this is the minimum point. So now let me give another example related to this. So now probably you have already figured it out. If I take fx as x cube, so what happens is that your f prime x is 3x squared, and that gives you x equals to 0. So this is your stationary point, and your f double prime x is 6x, which is again 0 at x equals to 0, and your f triple prime x is 6, which is greater than 0. So now is x equals to 0, point of inflection here. So what would be the answer in this case? You can type your answers in the chat. Okay. Yeah, two people replied. And, okay, so I think this, you know this answer. Yeah, three people already replied. So it's yes, that's obviously the correct answer. So if you see this, so what happens here is that this is the highest derivative, highest order derivative, which is z, and this is an even order. So that's why it's a point of inflection. But if you want to understand it more graphically, so now I need to draw x cube, fx equals to x cube, uh, something like, yeah. Yeah, so when x is greater than 0, it takes positive values. When x is less than 0, it takes negative values. And this is neither a minima nor a maximum. So now why it is called as an inflection point. So suppose you take like very small value, epsilon, which is epsilon greater than 0. So that will give you epsilon cube. And if you take minus epsilon, so that will give you minus epsilon cube. So either side of this point, in one side, this function is like taking positive values, other side it is taking a negative value. And also this side, this function is kind of increasing. And if you go this side, your function is kind of decreasing. So that's why it's called as a point of inflection. So, so one side the function value is increasing, and on the other side, the function value is decreasing. So that's why it is called as a point of inflection. So I think you will again get similar questions related to this in your assignment, like tell me like whether it's a point of inflection, whether it's a stationary point, whether it's a maxima, whether it's a minima, something like this. And I think you know the technique and you'll be able to solve this kind of problems pretty easily. So that's all about this stationary point, maxima, minima, and point of inflection. Later, what I wanted to discuss is functions of multivariable, multiple variables. So now, suppose f is a function of x and y, two variable function. Suppose I write it down as say x square plus y cube. Uh, the question is find the gradient and the Hessian matrix of this function. So suppose we have a function like this, as I have written it down already. So this is how you write your gradient. So can anyone tell me what goes here and what goes here typically when you try to find the gradient of a function? Anyone can unmute and answer this. I hope you have studied this in the lectures. I think this was probably there. Uh, Actually, this I think what you are telling is a Hessian method. Yeah, yeah. So it's not the gradient, I guess. Okay. So anyone else, or probably I can answer it. Yeah. So what Diksha mentioned is a Hessian matrix expression. So what you have in these two positions here while finding out gradients, I'll write it down. So it's like to take the partial derivative of this function with respect to x here, and here you take the partial derivative of the function with respect to y. So this is your expression for the uh, gradient. So now after this, now can anyone tell me what goes here and what goes here for this function x squared plus y cube? Uh, yeah, you can unmute and answer again. Anyone? Yeah, that's correct. Okay, so this is fine. Now, let's write the expression of the Hessian matrix. So you can write it as something like this. Now, this will be a 2 by 2 matrix. And as Diksha mentioned earlier, so already you have this in this location. So what you do, you take the derivative again with respect to x here and also y. So this will become like this. This will like become del y del x, and I think I've written it wrongly. But yeah, so what you do is you take it as something like this, and this lower portion again you do the same kind of thing, and this will be your del f of del y. I think this should be del 2f anyway. I have written it correctly now. So now our function was, so our gradient was this. So now looking at this gradient, can anyone tell me what goes in this four locations here, 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 and here of this matrix? So yeah, again, anyone can unmute and answer. I think then only you'll be able to understand it better because you'll get a lot of questions like this in your assignment. Yeah, Manohar has raised his hand. Anyone else, like someone new this time probably, or otherwise I'll go to him. Uh, Let me wait. Okay, Manohar, you can go ahead and answer this. Yeah, that's correct. Yeah, that's correct. Okay, this is 0 again, and this is 6, 5. So this is correct. So let me ask you this, like, has everyone understood this? whoever is in the call, because this is like pretty basic. You will get a lot of questions related to this, and also like unless you find your Hessian matrix, you cannot able to like proceed with other questions related to, like there will be other questions like convex functions, eigenvalues, determinants, traces. A lot of things will be there. So probably the other tier will be discussing those. So has everyone understood this one? Uh, yeah, so you can ask me in the last 10 minutes. I'll be wrapping up in the next 10 minutes and then you can ask it. Yeah, sure. Not a problem. Probably for assignment questions, I cannot directly answer those, but if you have like doubts regarding like understanding or if there is any mistake in the question, I can able to like clear it. Not a problem. Okay. Yeah, sure. Okay, so this is your Hessian matrix. You can probably write it as H as well. So not a problem. So now probably you have a question related to like what is the value of the Hessian matrix? What is the value, or like what is the Hessian matrix? It's not a single value, it's a matrix anyway. So what is the Hessian matrix at say 1 comma 1, something like this. So what you need to do, you have your H and you put 1 comma 1. So your x equals to 1 and y equals to 1. So it's like your 6 multiplied by 1. So this is your 2006. So this is your final answer. So you probably will get questions related to this one. So I think this is pretty clear. So yeah, so probably I wanted to discuss this, but let me go one step further and take another. So this will be my example. So if this is one here in this module, yeah. So let me now take a function of three variables. Now, can anyone tell me what will be the size of this gradient? So like it will be a vector. What will be the size of this vector? Can anyone tell me? Unmute and answer. So like how many elements will be here? No, it's a gradient. It's not a Hessian. So that's I think I'm noticing this confusion with all of you. So gradient is like finding out the first derivative. It's not nothing to do with second derivative. So suppose you were, yeah, it's three. It's like 3 by 1. So you will have 3 rows and 1 column. So I think since there are a lot of doubts related to it, suppose I have a function of one variable. When I ask for a derivative, it's like the first derivative I'm asking for, suppose. When I'm asking for double derivative, this is what you do. So think this as equivalent to Hessian in a multivariable space. And think this equivalent to your gradient. So whenever I am asking to find the gradient of this function, so what you do, you just take the first derivative. So this is you're nothing but df by dx, right? So here you have three variables. So you do df by del f by del x, del f by del y, del f by del z. So this is partial derivatives here because you have a function of multiple variables. So that's what you need to do. You don't even bother about like having some other elements like double derivatives and so on. So since there are three variables here, the thing is that you can take derivatives, first derivative with respect to this three variables only, x, y, and z. So that's why there will be three elements only. It's not like 3 by 3 or anything. That would be a completely different problem. Like you like solving Hessian for Hessian matrix. That's a different thing. So now if you solve this, I think this computation you can do. This is 2x, 2y, and 2z because these are partial derivatives. You won't have terms related to the other. These anyway doesn't contain terms related to x or y or z, something like that. Now, suppose I ask you to find out the Hessian matrix of this. Now it will be a 3 by 3 matrix because what you do now, you have three variables, and for every row of this uh, gradient, you can take the derivative with respect to the three variables again. So now it's something like this. Sorry, this will be x because we're just considering uh, this first term at first. Then again, we will be working with the second term. And for the third term, similar things will be there. So now this will be your 3 by 3 matrix. And here you will get 2x. If you take the derivative with respect to x, is 2. For others, is 0, 0. So you will get something like this. So this will be your Hessian matrix, and its value is same at every x, y, z point because ultimately you don't have any term containing x or y. So since there are so many doubts, let me like stop with a simple another example related to this because I think we're having a lot of doubts related to this. Now suppose let me quickly give an example of two variables only, square y plus x square plus x cube x y cube. Now this one I want to get it answered by you only. I'm not writing it down. So what will be, so I'm telling you that it's just two terms because you have two variables, x and y. So what will be the values here and here? Just tell me someone. Values here and here. You can unmute and answer this. Yeah, this will be y square plus 3x square y cube. So this is good. The next one, yeah, yes. So I think, yeah, then you are able to handle this kind of problems as well. And for the Hessian matrix, so I'm again telling you like, so always remember if there are n variables, so here n equals to 2, then the size of this will always be n times 1. This is the gradient, and the size of the Hessian matrix will always be n times n. So here it's 2 by 2. So here there will be a term here, here, and here. Can anyone again tell me what will be the values here? 6xy cube. Okay. Uh, this this one. Yeah. Mhm. Yeah. Yes, that's correct. And what will be the value here? This one. Yeah. Yes. Hmm. That's correct. Uh, yeah. Six. Y x cube. Yeah, that's correct. That's correct. Yeah. Yes, this is correct answer. So that's how I need to solve this for Hessian matrix. And then you can put, suppose it's being asked like, what is the value of the Hessian matrix at 1, comma 1? You can put the values x equals to 1 and y equals to 1, and you will finally get the value of like your Hessian matrix can be computed. And then there can be a lot of questions related to the Hessian matrix, and those kind of things will still be there in the assignment. So I think I'm not going into that in this session. Probably the other team might be covering that. I'm not pretty sure about that as well. So now, how much time do I have? I have still some 8 minutes. So yeah, Diksha, you had a question. You can go ahead. Yeah. Uh, so what you are telling is that suppose, uh, yeah, you can show it, not a problem. Uh, let me just open it. You can you just tell me which question you are talking about? Okay, first assignment question. Then I'll just check and tell you. Yeah, just a minute. Yeah, so you were asking for the 10th question. Okay. Yeah, so okay, so I think there is some issue with uh, okay, so the Hessian matrix is being asked, right? The 10th question you are talking about. Yes, so you're saying that it will be in terms of x and y and y, how we can get the values. Okay, yeah, so actually, if you remember, I gave you this example. You can unmute. I think some echo is coming from your end. Yeah, now it's fine. Yeah, so I think I gave you this example, right? So here the function is x squared plus y squared plus z squared. If you notice here, your Hessian matrix was directly like this. It's not even having terms related to x, y, and z because this highest power was of 2. So I think something similar will happen when you solve that problem. Your ultimate expression for the Hessian matrix won't be containing any x, y, or z. So, or I think that was the problem of two variables. So it won't be containing x or y. Uh, yeah, so it was a two variable problem. So in that case, what will happen? It will take the same value at every point. So that's the idea of that question. The question is perfectly fine. I think when you solve it, you will get the answer. So not a problem. So have you understood this, Diksha, or you still have some doubts related to this? Yeah. So the tech. Yeah. Go ahead. Okay, okay. So in that case, I think I don't think that will happen. But if something like that happens, then we'll understand that it's a wrong question or something. Then we'll not be evaluating that question. So that's not a problem. Yeah. So yeah. So Anyone else have any other doubts related to assignments? You can ask now, I think. Still have some 3-4 minutes left in my session. Yes, I'll be sharing these notes. And yeah, every class I'll be sharing these notes. I'll be uploading it to a Google Drive. And also this videos, I'm not sure, probably the NPTEL team probably making this available. I'm not sure, but I'd recommend everyone to attend this live because you can ask your doubts. That's the biggest plus point in these sessions. And also, I'm solving this problem. So if you solve it with me, I think the assignment questions will be a cakewalk. You can just solve it in a few minutes or something. So that will save your time. That's the thing. So yeah, and if you go back to yeah, yeah, and these videos, even if they're available, it might happen sometimes that there is some lag from this net issues or something. So I'm not sure whether that worked out fine today or not when I was writing it down and when I was speaking, whether that was in sync or not. So I hope you have understood these problems. So yeah, so the other TA I think will be taking a class from 4, but I still have some 3 minutes. So let me conclude this. So I think one thing I still wanted to discuss with drawing of feasible regions. So I think you will get some questions related to this as well. I think mm, uh, this was, I think, there in your first week zero assignment as well. Some similar questions where like you have given some equations, say x plus y less than equals to 2, then x minus say y greater than equals to 3, then you're something like this. So this way, I think what you have to do is that if you take x plus y less than equals to 2, so first you will have this line of like x plus y equals to 2, and then you have to denote the region. So if you put the origin value here, x equals to 0, y equals to 0, you'll get 0 less than equals to 2. So origin is a feasible point. So what you get is that this is your feasible region for this equation. Then we'll get this x minus y greater than equals to 3. So if I put, so that will go through, say, equals to 3. So when x is 4, y will be 1, something like this. So, but here also, if you put 0 and 0, origin is not a part of it because 0 is not greater than equals to 3. So this will be like directed in the opposite side. So here, finally, you might be asked to like tell, or you might be having y greater than equals to 0, x greater than equals to 0. So you might be having some feasible region like this. So this kind of questions might also be there. So be prepared to solve this as well, where you'll be given some equations and you have to draw the feasible region, something like this. So yeah, so that is probably all. Any last minute questions or anything from anyone? Any feedback or anything? And if you have like further doubts, you can always post it in the discussion forum of the course page, and I'll be able to answer it, I think, throughout the week. And next week, again, the plan will be similar. I'll be discussing the week 2 assignment questions. So I won't be discussing them directly. I'll be again taking some similar examples and related problems I'll solve. So that is all from my side in this class. And anything else from you? Then otherwise I'll close the session in a minute or something. And do join the other session that's there from 4 p.m. Yeah, I think it's 4 anyway. So it's 4, so I'll be closing this session. So thank you all for attending it. And yeah, do attend it in the next week and good luck with your assignments.